Hi everyone, we are looking at reduction of grammar. This is the first part where I'm going to show you how to remove useless symbols. Now, here's our given grammar. Okay, there are two phases in this type of problem when we have to remove useless symbols. In the first phase, we focus on the terminals, which can be achieved by this grammar. So let's start with terminals. Terminals are basically small letters on which a string can end. So over here we've got A, okay, then we've got C. Notice how I'm not taking B or any other E. Why? Because they are joined with their symbol, also known as variable, which will call itself. So this is not a terminal. It doesn't comply to the concept of terminal on which a string can end. Therefore, I've taken two terminals, A and C. The next step is we focus on the variables or non-terminals that can be accessed by these two terminals. So A can be accessed by S, okay, and A can be accessed by A itself. Then we've got C. C can be accessed by C itself. In the next step, we see how these three variables can be accessed by other variables. So which variables will those be? So S is accessed by D. So we include D. A is accessed by A itself. We're not going to write that. And C, we've already mentioned C. So we're not going to write that again 2 times. Okay, so we've only written it 1 time. Then C, which variable accesses C? C is accessed by C itself and E. C, we've already written C. So we're going to write E over here. In the next step, we see that which variables access these elements of the set. So we've already established the fact that S is accessed by S itself, D, only D. A is accessed by A itself and C. C is accessed by C itself and E. E isn't accessed by any other variable. There are no variables left, by the way, and D is also not accessed by any other variable. So when our last set becomes equal to the previously found set, then our answer will terminate or end. So this is the answer of first phase. Now before moving on to the second phase, we complete phase 1 by deriving its grammar. How do we do that? First we make a set, let's say G dash, then we write the non-terminals, then we write terminals, then we write production rules, then we write the starting variable S. S is the starting variable. Over here, production rules, we see that since we've only omitted one variable and that is B, so from all the production rules over here, we're going to remove B. So this is going to be removed, this is going to be removed, this is going to be removed. After this, we get this set of production rules. Now on the basis of this, we form our phase 2. How do we start phase 2? We started by the starting variable, S. Now we see that what or which variable can S access? S can access right here C and A. So we're going to write C, A. Now we see which variables can access S, C and A. C can be accessed by A, capital A, and that's it. We're going to repeat everything. And C can be accessed by this terminal C also, so small c over here also. Then we see that which variables can access A. So this is going to be repeated because only A can access itself, and we've already written small a. Epsilon we do not write. So therefore, this was y1, this is y2, this is y3, y4. y3 and y4 are equal. So last set and the previous set to the last is equal. Therefore, our answer is complete. So we formed this grammar of the second phase, which concludes that our non-terminals are these. Sorry, this is mistake. Terminals are these, production rules and starting variable. Now we look at the production rules. Based on these non-terminals, we find S goes to C and A goes to A, and epsilon, C goes to C, C, A, C. So over here, we find that these two variables, D and E, were unreachable or unapproachable by S. Therefore, in phase 2, we are going to omit them also. So phase 1 is we remove that doesn't generate, the variables that do not generate, and phase 2 we remove the variables that are